All right, thanks, Wendy, and good afternoon to everyone. I'm Tony Bergantino. I'm the director of the Water Resources Data System in the State Climate Office. Welcome to the first webinar of Water Year 2025. The webinar is being put on by my office along with University of Wyoming Extension and USDA Northern Plains Climate Hub, Wyoming State Engineers Office, US Geological Survey, Bureau of Land Management, the Weather Service Office in Cheyenne, and the Missouri River Basin Forecast Center. So today we'll be taking a look at the climate and drought conditions, wildland fire outlook, reservoir ops, surface water rights administration, stream flows, forecasts and outlooks. And since this is the new water year, each of the presenters will also be showing some summary slides of what was going on during the previous water year. So before we start, just a quick public service information announcement. If the skies are clear, they're not here. You got a once-in-a-lifetime opportunity to see this comet. Took this over Sheep Mountain, west of Laramie, and it becomes visible to the naked eye around 7:30 p.m. or so, depending on your location. So I invite you to go out and try to locate it. All right, on to the drought map. Not to sound too much like a broken record, but again, drought map just released today is looking worse than the one we showed during the last webinar. It did have one area of improvement in the Northwest, highlighted there in green, but we had a number of degradations over the last few weeks. Okay, kind of looks like I turned a cat loose with a crayon here, but the red areas show one category decline or degradation since the last webinar. And those dark red areas, those areas declined 2 categories in the last month. The orangish areas, I put those in those little islands there because there were some areas within the degraded areas that did not change one way or the other. So those areas that stayed the same amongst all that other big changes are highlighted there in orange. Of some significance is the D4 or exceptional drought now showing up in the Northeast. This is the first D4 that has been in Wyoming since about a 12-week period. It was from July 13th to September 28th of 2021. And there was about a little less than 0.1% covering a small portion of south central Wyoming. But now at 0.82% of the state, this is the largest area of D4 that we've seen in Wyoming since the week of April 9th back in 2013. So over 10 years ago. Drought last year there on the left, brief period where the entire state was devoid of any D categories. We now have declining starting again down there in south central Wyoming, where some abnormally dry and moderate drought began to appear a year ago. But fast forward 1 year and those conditions expanded and worsened over time, and now we're seeing what we got over here on the right. All right, panel showing, this is a little different. I've got and put a couple extra years in here. It's showing the current drought monitor on the lower right, but also then 5 other periods of intense drought during the state. In the early 2000s, the drought across the top, we had some periods of time when almost the entire state was in D3 or extreme drought or worse, and the expanse of D4 is considerably larger. The drought of 2012, 2013 is down here on the lower left and shows about the pretty close to the worst extent of that drought period. While the map in the lower center is the more recent one, that's showing the near peak extent of drought conditions during the last drought. So here we have about 25 years of drought levels in Wyoming. On the far right, you can see the increase in D3 starting, as well as an extent of the state covered by a D category shooting up to 100%. In terms of actual drought, those D1 to D4 categories, well, it's probably better shown on the next slide. Well, maybe not, since we've only got 1 week of data showing here. But the D1 to D4, the true drought categories, is now sitting at 100%. And this is the first time we have seen that in over 20 years. The last time that the entire state was in D1 or worse was September 21st back in 2004. Since the last webinar last month, the percent of the state in D3 or that extreme drought has gone up almost 16%. So we're currently at 23.79%. And as mentioned, there is now also just under 1% of the state covered in exceptional drought, or D4. Precipitation over the last 2 weeks, the less said about this, the better. The last few weeks have been dry. My own stations had a stretch of 29 days in a row with no precipitation, and that's not a record though, but it did tie for the 10th longest consecutive stretch of days with no precip, and that's with a station that started back in 1966. I will note, though, that 12 minutes before this webinar started, it did start raining here, so there goes the run, and we're going to be popping the bottles here pretty soon, I think. Only the Northwest and an area on the Uinta-Sweetwater County lines saw precip amounts in the last 2 weeks that were over the second percentile. Looking back at the situation over the last 3 months, it's a bit better, but still bleak. The far Northwest saw precipitation percentiles around median, while Laramie and central Albany counties did see totals that actually exceeded the median, but the rest of the east, northeast, along with south central Wyoming and other areas were all under that 10th percentile. So after a few months of my showing how similar the water year and calendar year precip percent of averages we're getting, we've got a major divergence. The reason for that is, well, with only a little over 2 weeks or so into the new water year, happy water year 2025, that means the percent of average we are seeing on the left is only for precipitation that has fallen or not fallen since the 1st of October. And that's been pretty minimal. Almost the entire state is under is under 5% of normal, except for a few little areas there up in red there that are under the 25th percent. On the right, calendar year just keeps trucking along, so not as bad, but if you were to compare this to the map that was shown during last month's webinar, you'd see a lot less gray and green, which are those areas of normal to above normal precipitation. So this shows where we ended the water year in terms of precipitation as a percent of normal. You do see some greens indicating as high as 110% of normal for a few areas, and larger areas of gray, which were right about the normal for the water year. Those are all mostly scattered throughout the central third of the state, from the Bighorn Basin down through the Great Divide into the Little Snake Basins. To the east and west of that are some pretty vast areas that ended up about 70 to 90% of normal for the water year, a bit under 70% up there in the northeast. How do we do for temperature? Well, on the left is the actual temperatures. This is actually a 365-day map, and since 2024 was a leap year, it starts on October 2nd of 2023, but that temperatures on October 1st aren't going to really change that map in any way that you'd notice. Average annual temperature around 50 or so in Platte, Goshen counties, along with parts of Weston and Niobrara and a few other small areas. About 45 to 50 for the rest of the eastern Wyoming, east of the Bighorns and Laramie Range. Oh, and much of the Bighorn Basin there as well. The higher elevations, of course, saw much lower average temperatures for the year, as did the Upper Green, roughly Sublette County, where the lower elevations all in the upper 30s or so as an annual average. On the right is the departure from normal, and much of central and south central Wyoming was within a degree or so of normal. The yellow areas, those are about 2 degrees above normal, and the orangish areas up to about 3 degrees above normal. You can see Central Platte County having an area up about 4 degrees above normal for the year. All right, I won't go into any of these specifically, but the active co-op stations in Wyoming, here's a breakdown by number for the water year of how many stations set various records and the number of those records that were set. So from left to right, after the total number of stations setting records, we've got a column showing record maximum temperatures. And then the next column is a little bit less commonly heard, but it indicates the number of stations setting. It sets a record for the lowest maximum temperature. Then we next move to the highest minimum temperature, and then some stats for the number of record low temperatures set. Last 2 columns indicate how many monthly record highs and lows were set. So if you're interested in seeing specific stations, get a hold of me. My contact info will be at the end of the presentation, and I can show you how to retrieve the actual records for any of these stations as well as quite a few others. So here's the standardized precipitation evapotranspiration index, the SPEI. It shows extreme short-term dryness. That's at the 60 and 30 days across the top, or much of Wyoming. The 1-year depiction down here on the lower right, showing dryness as well. And the progression is increasing in intensity as you see it move from the 1 year to the 60 and 30 days. So that indicates a decline in conditions that we're all pretty well aware of. Nighttime temperatures getting down into the 30s for the last week in all but a few areas. Those are shown in red or dark orange. Upper green and higher elevations seeing lows below freezing into the mid to upper 20s, but as far as departure from normal, only a few areas in the state at normal or below normal. The gray or even the small spots of green on the map down here on the lower left. For this webinar, given how high the departures have been, I switched the map back to one having a range going from 15 degrees below to 15 degrees above normal, unlike the ones that I was showing the last few months, which had a more compressed range of 10 degrees below normal to 10 above. The remainder of the state seeing lows that were 2, or in most cases, 6 to 12 degrees above normal for the lows over the last 2 weeks. Now the daytime highs over the last 14 days up here on the upper right, still in the 70s for much of the state, other than the high elevation areas as usual. And even there, the temperatures were still in the 50s. Down here, departure from normal was greater for the maximum temperatures than it was for the minimum. This one's easy. The entire state was more than 10 degrees above normal, and this holds true in all but a few small areas for actually the 30-day maximum temperatures too. Most of the state was greater than 12 degrees above normal, and some areas such as the west and north central saw average highs over the last 2 weeks that were more than 15 degrees above average. Soil moisture, all of Wyoming is now below the 30th percentile, with most of it actually being below the 20th percentile. And there have been declines all across the state. The only places you can't really see between the two maps where there have been declines are that 0 to 2 percentile, and that's because that's the lowest range there is. Not much difference comparison with the veg dry maps this week compared to 2 weeks ago. Bit more green in Teton and Park counties, along with southeastern Sweetwater County. As has been the story for the last several months of showing these, no real comparison with a year ago on the, except on the Albany County line, Albany-Platte County line, where conditions could be argued to be a little bit worse this time than they were last year over here on the left. Snow water equivalent. This is the slide I showed last month following a widespread appearance of snow up there in the higher elevations. I said then not to read too much into this, and this is why. It's all gone. And here we have snowpack. This is a bit of a recap on April 1st of this year. That's generally considered the peak snowpack, although that obviously varies by basin. Some basins hit their peak this year about 2 weeks earlier, between 0 and 2 weeks before the April 1st, and as much as 2 weeks later than April 1st. But generally, they look at April 1st. We see snow water equivalent in the normal to above normal range, with exceptions shown here in yellow, orange, and purple. Belle Fourche and Cheyenne and purple were at their lowest for much of the season as snowpack built. It was at the minimum that's ever been seen, or at least since about 1980. Although they did pull out there near the end of the season when we were getting more towards the peak. The powder and orange was setting minimums all throughout the season as well until about the first week in April, and then actually did get above median for about 2 weeks or so leading into the meltout, but it wasn't enough to really help conditions up there. And the lower green, the Bear, and the Little Snake basins were the only ones to exceed their median peak snow water equivalent values. Although you could make arguments that Snake and Sweetwater Basin tied it. It was right around the median. A few other basins did make some valiant attempts, but they fell short. So it was only those few basins that actually made median peak snow water equivalent this year. So with that, I'll turn it over to Aaron Fiaschetti, who's with the USGS, to let us know about the surface water conditions. Aaron?
Hi, Tony, and everyone. Thank you. So here we're looking at a map of Wyoming from the National Water Information Dashboard. And this showing gauges as dots on the map for real-time flow. And the green range is what the USGS considers to be normal. It ranges from the 25th percentile, which is a lower flow, to the 75th percentile, which is a higher flow. And they're considering anything in that range to be normal. The central tendency there would indicator would be the median. So, but if you look around at these kind of green dots on the map, most of them tend to be below the median. Flows are not that high right now. In the western part of the state, we have a fair amount of oranges, which are below the 25th percentile. So that's a below normal. That's a pretty low flow. And then reds, which are below the 10th percentile, which would be a very low flow. And it looks like we have one flow that's an all-time low for this day, coming out of the south end of the Wind Rivers there. So generally, flow conditions are below the median to very low right now. Next slide. So looking at kind of a longer time step, this is a 28-day average, so an average of mid-September to mid-October, and this is a product from Water Watch. We see pretty similar conditions, not as many gauges there, but generally you're seeing quite a bit of red and oranges, which are below normal to much below normal throughout the western and southern part of the state, and then some normal conditions. And normally about this time of year, we should be receiving somewhat normal, some precipitation that would boost stream flows to get them a little bit higher, but I don't think we're really been seeing those increases in flow. So generally these monthly conditions here, the 28 days, are showing what we're seeing in the real time. So moving on. So normally I'll present kind of a duration hydrograph, but was asked to kind of wrap up the water year. So what we'll be presenting this time is a cumulative hydrograph. And this hydrograph is in millions of acre feet. An acre foot is 1 acre of land with a foot of water on it. So it's 1 CFS is 1.98 acre feet per day. So just taking a look here at the North Fork of the Shoshone, and these hydrographs are pretty similar to what I showed before. That green range is showing the 25th percentile on the bottom and 75th percentile on the top. The median is kind of right in the middle. That's a kind of a dark line. And then they have the lowest observed and the highest observed, and the black is 2024. So showing here that at the South Fork, the Shoshone coming out closer to the 25th percentile than the median for the water year. And you can kind of see early in the year, pretty good flows, October, November, December, above average, but that's not when the water comes. The water comes in runoff, and that runoff lagged and just kind of left that gauge. The volume of water that passed that gauge October 1 to September 31st is closer to the 25th percentile than it would be to the median. So not a great water year on the North Fork of the Shoshone. Moving over to the Bighorn, this will be one of the few examples of coming out close to the median. So Bighorn River at Kane, pretty normal water year coming out at the median. So that's pretty reasonable flow for 2024. Things looked pretty good on the Bighorn River. Moving over to the Powder, Middle Fork of the Powder. So the units are still working in millions of acre feet, but the previous was in closer to 1 million acre feet. We're talking 40,000 acre feet, so a much smaller stream here. But good flows above the 75th percentile on the middle fork of the Powder there. So that's kind of the winner of water supply, it seems like, in Wyoming. But a much smaller watershed, had a good early season into the winter, and then runoff panned out pretty well there on the middle fork of the Powder. Moving over to the North Platte above Seminole Reservoir, that black line, it's a little bit below the median. But it looked like it kind of paced the median pretty well till runoff ended in early July, and then kind of fell behind a bit. So it's a little bit below the median, but it looked like to be a reasonable water supply year on the North Platte in that location. And then moving over to the Green River at Warren Bridge. Flows look good all through the winter into spring, and then runoff really never materialized as that black line in April, May, and June. Not a lot of water there, and then lagged right around that 25th percentile, maybe a little bit below, and kind of finished the water year out. So that cumulative volume was closer to somewhere around a couple 100,000 acre feet, instead of something that should have been closer to 5 or 6,000, 100,000 acre feet there. Moving over to the Snake River above Alpine, pretty similar conditions here. Things looked pretty good till runoff started, and then the cumulative flow there started to lag behind. So working a little bit bigger numbers here. We're closer to 2 million acre feet at the end of the year. But still closer to the 25th percentile than the even close to the median there. And then looking at reservoirs, not a time of great water supply, not a lot of water moving around right now. So most reservoirs around the state decrease storage a bit. Some of that could be water use or decreasing storage for operational reasons. So across the state, most major reservoirs are somewhere between 50 and 90%, depending on the location. And one reservoir of note, it seems the Palisades has been decreasing quite a bit. It's right around 37% full right now. And then the last slide. So just kind of a general snapshot of the water year. And this is a duration hydrograph that's an amalgamation of different gauges. And that unit is a runoff in millimeters. So it's runoff per kind of square mile is that kind of that unit. But the general kind of that hydrograph, I think, kind of paints the water year pretty well, where coming in early in the water year, things looked pretty good till we got to about runoff. There was a short peak, and then flows dropped into that 25th percentile or less, with a lack of precipitation and a lack of substantial snowpack in the mountains for this year. So most locations probably had a cumulative flow below the median. There wasn't really much of a peak this year or any real high flows. And then after runoff, tended not to get a lot of precipitation to sustain those flows. And we're seeing that into the fall, where those fall precipitation isn't really materializing in a way to really keep flows elevated or bring them out of those low flows categories below the 25th percentile or even lower. So that's all I have. Thank you very much.
All right, thanks, Aaron. Now we'll go to Liz Cresto with the Bureau of Rec to look at operations of reservoirs. Liz?
Yes, well, thanks to the USGS, I don't have to cover inflows to our reservoirs, and that kind of explains some of the reasons why the reservoirs are where they are at right now. So I'm Liz Cresto with the Wyoming Area Office, Bureau of Reclamation. So I'll only be covering our facilities in Wyoming, which include the Bighorn Basin and the North Platte. So as the USGS stated, We had some good inflows at the beginning of the year, but things kind of tailed off. And that's what you're seeing at Buffalo Bill. The storage at the end of the water year ended up at 400,000 acre feet, or 88% of average. So the irrigation entities used a little more storage this year than they have in the past. Boise end of the year storage was 573,000 acre feet, or 99% of average. Switching over to the North Platte, where we talk about ownership, there was no allocation on the North Platte this year, and that's because our supply was greater than 1.1 million acre feet, which is considered a full supply. In terms of ownership, the Kendrick ownership, which has space in Seminole and Alcova, ended the year with 92% of average. Glendo ownership was 100% of average. And the North Platte ownership, which is a combination of Guernsey and Pathfinder storage rights, ended up at 99% of average. Next slide deals with our generation. We have 11 hydroelectric power plants, and the 4 power plants on the left are the 4 power plants at Buffalo Bill, then Boise shown in the middle, and then the remaining on the right are the North Platte power plants. And the blue line shows how much we generated in 2024, while the orange line shows the 30-year average. So we generated about 959 gigawatt hours, which is approximately enough power to supply 84,000 homes. The total generation value was about $36 million, of which most of that comes from the North Platte facilities, which was about 28 million, while the Bighorn, which is Buffalo Bill and Boise, generated about $8 million through that power generation. So switching over to where we are right now, Buffalo Bill, we stepped it down today and are going to continue stepping down to our winter flow rate of 260 CFS as measured at the river gauge. And this is determined based on a winter flow agreement, which is an agreement signed between the state of Wyoming and Bureau of Reclamation. So that's where we'll be for the remainder of the winter. Boisen's at 700 CFS, and that's also our winter flows this year, and Bull Lake is at 40 CFS currently, and they'll remain there for the remainder of the season before runoff, or through early runoff. Next, switching over to the North Platte, irrigation season is over there, and we're also at our winter operating levels. So we're at 530 CFS below Seminole and Cordis. Pathfinder releases will be 75 CFS below the dam. Alcova Reservoir will be lowered 10 feet during the month of October to the winter operating level of 5,488 feet. Gray Reef releases are at 500 CFS. We're currently ceased releases out of Glendo so that we can do a river crossing reconstruction there. And Guernsey releases have also been discontinued for the season. That's all I have. Thank you.
Thanks, Liz. So now we'll go over to Michelle Hubbard from the State Engineer's Office and go over a summary of Surface Water Rights Administration.
All right. And so my name is Michelle Hubbard, and this map shows the water divisions in the black lines and then the districts within each division as the blue lines. And so the districts that are highlighted red represent any basin that was under an administrative call for water year 2024. A majority of these calls were placed for a senior water right, getting their water rights. And I don't know if you're able to see, but there's smaller numbers in these small subbasins that show their calling rights. And so starting in the lower right, we have Division 1, and the range of calling rights is 1875 to 1969. And really quick, just because the calling right is 1875. That does not mean every single right junior to that is shut off. Essentially, whenever there is a senior user that places a call and it is approved, then a hydrographer goes out and moderates all of the ditches and all of the users to make sure that that senior user gets their water right. And it changes frequently throughout the season depending on the amount of water in the streams. So a wide range of calls, but again, we go back pretty deep into our seniority. Division 2, the upper right portion of the state had some calls as well, and their ranging from 1882 to roughly 2001. Most of them were in the 1880s. Then moving on to Division 3, which is the upper left corner of the state, we had a range of calling rights from 1877 to 1906. And then last but not least, Division 4 in the lower left part of the state is ranged from 1878 to 1918. So a big impact that you have on regulation is your water supply. When you have not a lot of water, a lot of senior rights end up calling. And so to compare water year 2024 to a better water year, or a year where there was more water, the next slide shows 2023 water calls. So you can see there is a lot fewer calls. There are still in each division some older rights calling, which makes sense. There's just some systems where usually there's a call based on a water right. There also are calls that are just for compact compliance or reservoir storage. So there's a lot of information in here, but that is about all I have for you today. So hopefully water year 2025 shows a map with no red. We'll see.
Let's hope. Thanks, Michelle. All right, now we'll go towards an eye on what's coming up for forecasts and outlooks. So we go to Tony Anderson over at the National Weather Service in Cheyenne. Tony?
Oh, thank you, Tony. I'm Tony A as opposed to Tony B. We'll start with our hazard calendar, and it's just a time display of the year with the most common fire or weather hazards for that given time of year highlighted in yellow. And at this time of year, it's hard to imagine winter storms given the weather we've had recently, but easily within the window of winter storm time. And ice jams are a possibility, not likely at this time due to the extremely warm weather. And then, of course, we're moving into the winter time and the potential for high winds. We are moving into an El Nino season, or so it seems, and El Nino tends to bring high wind with it. So definitely a possibility, but right now looking pretty calm relative to your normal Wyoming October. Next slide, please. Looking towards the 7-day forecast, we have an event coming in. Yay, as Tony said, it's even raining in Laramie already, or at least it was raining a few minutes ago. But we do have some precipitation coming in. We've got a series of cold fronts that are going to roll through starting right about now and going through Sunday. And various places in the state are going to get rain through that time period. Pretty much the whole state is going to get something or should get something. Unfortunately, it's not going to be a drought breaker. This is going to be a small event, and we're going to move back into warm and dry conditions on probably starting on Monday. So enjoy the precipitation while it comes. We should be getting some snow in the high country, but don't look for that drought map to change. If we may hold our own, but we probably won't improve anything. Next slide. Looking out to the 8 to 14 day outlooks, it's kind of a ambiguous outlook. And the temperature side, we have a weak signal for below normal temperatures in the northwest, and we have a relatively weak signal for above normal temperatures in the southeast. And then in between, we've got an area where there is no signal. So in those areas where there's near normal or no signal or equal chances, they change the language every now and then. Basically, that means your long-term average is going to be the best forecast you can make. And so right now we're pretty neutral. If we move over to the precipitation outlook, it's a little more easy to read. We have a weak signal for above normal precipitation across almost the entire state, except for that little bit down in the southeast. And that would probably reflect the storms we have coming in right now for this weekend. Next slide, please. Going out to a full month, talk about a uninteresting graphic. We have equal chances for normal temperature, or for above, below, and normal temperatures, and we have equal chances for above, below, and normal precipitation. So not a lot of signal there. Once again, your best forecast for this time period is probably going to be the long-term averages. Next slide. Okay, looking all the way out to the full season, and this should incorporate the El Nino effect that we should be seeing if the forecasts remain solid, or at least consistent with predicting an El Nino. But we've got some signals. We've got a weak to moderate signal for above normal temperatures in the entire state. It's weaker in the north and it strengthens towards the south. So a pretty good chance that we have a very good chance of seeing above normal temperatures for this winter time. That's a good thing. Unfortunately, the wind will make it seem colder. And then looking at the precipitation outlook, here again, equal chances. Our best forecast is going to be the long-term averages, except for a little bitty corner up in Yellowstone. And that's a weak above normal signal for precipitation. So not a lot of excitement on the precipitation side, and I wish it was much greener across the state, because I'm starting to worry about this drought. Next slide, please. We're going to look at the year in terms of accumulated precipitation and accumulated cooling degree days for the water year that's just ended, and they match up. The left side is the precipitation, the right side is the cooling degree days, and cooling degree days are a proxy for temperatures. It's a measure of how much energy was spent cooling houses and buildings and those kinds of things. So the average value is in brown, the observed value is in green, and you can see, except we're looking at Casper, Cody, and Riverton in these three sets of data. And you can see at Casper and Cody, we were well below average on precipitation, especially at the Cody gauge. Riverton, however, was pretty close. The thing to look at in these patterns, and there's another slide that looks like these, is how flat the green line gets at the end of the water year. That's what's going to tell us something about how we got to the drought condition that we're currently in. It's that as that brown line, that green line separate later in the year, that's where I think we're seeing that rapid intensification of the drought. Over on the cooling degree day side, the green lines now are the observed, and they are generally above the brown average line. And that's telling us that we spent more energy cooling than we do in a normal year, except for at Cody, which was just about normal. But on the other two, at Casper and at Riverton, we not an extreme amount greater, but there was a significant difference between the average and the amount of cooling degree days that we actually experienced. So next slide. Here again, same types of data, only 3 new locations, going from Cheyenne to Gillette to Green River down each column, and the same 2 separation in the data. And again, on the left side, the brown lines tend to be above the green lines, so the average is above the observed. And at Cheyenne, except for a freakish period in early August, that green line would be even further below the average. So we've got significant differences there, except in Green River, where they had just about a normal water year with regard to precipitation. Looking over on the other side, here again, or here for the first time, all three of these stations, you see a significant change between the average cooling degree days and the observed cooling degree days. So we spent a good deal more energy cooling buildings and whatnot this year than we did last year, especially down in the Green River gauge. That's a very significant difference there. So I just wanted to give you an idea for the pattern, and it hopefully helps explain some of what we're seeing in the drought monitor, in that the last 2 months of the year were extremely hot and extremely dry. And so if we'll jump ahead, I'm going to try and explain that with one more slide. The background here is the current drought monitor, and then I have those 6 gauges that we looked at plus Rawlins. The precipitation data, it shows a number and then a number in parentheses. The first number is the ranking of the precipitation in terms of lowest precipitation years, and then the number of years in the data set. And then the average temperature is the ranking for the highest average temperature in the August and September time periods. So as you look around those numbers, precipitation wise, Cheyenne and Green River were both above normal for the year, or for this 2-month period, mostly due to early August rainfall. The rest of the stations, however, are on the low side. The 12th lowest in Cody, 33rd lowest in Gillette, 20th lowest in Riverton, 8th lowest in Casper, and the 8th lowest in Rawlins. Now, those numbers are significant in that we are in many cases, we are very near the 90th percentile for those observations. But it struck me as being, it didn't quite correlate with the drought intensification that we've seen until I looked at the temperatures. So these temperatures are, again, these are rankings in terms of how close they are to the highest average temperature for that 2-month period. And in Gillette, this was the warmest year out of 116 on record. In Cody, it was the 8th warmest, Riverton the 8th, Casper the 10th, Cheyenne the 4th, Rawlins the 4th, and Green River the 5th. It's been very warm. And the drought intensification that we've seen over the last 2 months, I believe, I'm not a drought expert here, but what I'm seeing here is that this drought intensification, yes, it has a lot to do with limited precipitation, but the temperatures seem to be what is driving the rapid intensification of this drought and the depletion of our soil moisture that is one of the major components that goes into our drought monitor assessments and recommendations. That's what I have. Thanks, Tony.
Thanks, Tony. Now to Kevin Lau with the Missouri River Basin Forecast Center.
All righty. Thank you, Tony. Again, my name is Kevin Lau. I'm with the National Weather Service, Missouri Basin River Forecast Center in Kansas City. And for the next couple of minutes, I'll be providing a review of the 2024 water supply season. As most of you probably know, the National Weather Service provides water supply forecasts at several locations across the state of Wyoming, and those locations are depicted here on this map on this slide. These water supply forecasts are similar in nature to the water supply forecast issued by the Natural Resources Conservation Service. However, we use a little bit of a different method than the NRCS to produce these water supply forecasts. But the end product is the same, and that is the volume of water that's expected to flow past a certain location within a given amount of time. For the state of Wyoming, the National Weather Service issues an April through September volumetric forecast for the Missouri River drainage and also the Snake River drainage. For the Green River drainage, the National Weather Service produces an April through July water supply forecast. So the graphic that I'm showing today is not depicting forecast data, but observed data for the 2024 water supply season. It's intended to answer the question of just how well did Mother Nature treat the state of Wyoming for this past water supply season. Again, that season would be April through September or April through July, depending on what basin you're in. The percentages shown on this map in the black bold numbers tell you how much volume passed a given location this year with respect to the 30-year average. So, for example, in the top right corner, you see a value of 83%. Well, that 83% means that for the period April through September of this year, the Powder River at Moorhead saw 83% of the 30-year average volume going past that location. So looking across the state, you see that the North Platte River Basin in the southeastern portion of the state, it seems to have fared the best of all the basins, with percentages in the 90, mid to even upper 90% range for most locations in the North Platte. The Snake, the Yellowstone, the Bighorn, the Tongue, and the Powder, all located in the northern portion of the state and the northwestern portion of the state, they kind of came in second with averages in the 80s, 80% or so of the 30-year average. And then I guess you might say the loser for this year was the Green River Basin in the southwestern portion of the state, and that seemed to receive the lowest percentages overall, with percentages in the 70% range. And so again, this is just a review of the volume of water that we saw during the water supply season for this past year. And so that concludes the National Weather Service Water Supply Review. Thank you, Tony.
Thanks, Kevin. Now we'll go to Chase Lane with the Bureau of Land Management to look at the wildland fire situation.
Thanks, Tony. I know there's been a hot topic through this summer, and hopefully this is the last month that it is a hot topic, and we're kind of moving into a couple month period where we're not worried so much about fire danger. When we look at fire danger, you need a little bit of background knowledge. So one of the key components to fire danger is fuel moisture. This is the amount of water within a fuel type. And there's two different kinds of fuel types. You have live fuel types and dead fuels. Our live fuels, they're dynamic in that they go through a green up period and then they go into dormancy. So you're going to have some changes in live fuel moisture content through the year, excluding environmental conditions. So in the spring, whether it's a wet spring or a dry spring, those fuels are still going to absorb moisture and be less receptive to fire than they would be throughout later in the year when they've evaporated or dried out. And then dead fuels are going to be anything that isn't growing, so anything laying on the ground, your dead grasses, branches, trees, any combination of. And then in fire, we measure, we have these subcategories, specifically in regards to dead fuels. And they're broken into size classes. So your 1 hour and your 10-hour fuels, these are going to be your grasses and small twigs. These are going to change daily and even hourly. And then you have some of your larger fuels, which are going to be your 100 hours and your 1,000 hours. These are going to be larger logs or branches laying on the ground, where the fire danger associated with these fuels is more related to a seasonal trend and not so much day-to-day changes. And then another thing we look at, which kind of plays into some of the fires we're seeing right now, is fuel loading. Really, this is just a measure of how much fuel is within a specific area. And the higher the fuel loading, generally, the harder they are to suppress. So some of these fires that we're seeing around the state, and you can see this, the fires have come out into the grass and sage where they have less fuel loading. We've been more successful in putting them out. The parts up higher on the mountain where there's higher fuel loading, there's a factor of reasons why they're harder to suppress there, but fuel loading is definitely one portion of that. We can go to the next slide, Tony. So we're going to look at a handful of charts around the state. These are looking at ERCs, or any energy release components in fire. This is one way that we measure fire danger. The blue line is going to represent this year. The red line is going to represent the maximum. And then the gray line is going to represent the average. So right here, we're looking at the northeast corner of the state. You can see, and this is for October 14th, so there's a couple day lag on it. We're above the maximum. So October 14th of this year, we're setting the highest energy release component than we have in this period that has been analyzed. And generally, we're analyzing a 10-year period. Sorry, I lost my train of thought there. You're going to see a significant decline over the next couple days as we receive some moisture. And then looking farther out, that's really just going to depend on the moisture that we receive throughout the fall. We can look at the next slide. Is going to be 1,000-hour fuel moisture. Same thing, blue is representing this year, red is, and fuel moisture, we're going to represent, the red is going to be the minimum or the lowest recorded 1,000-hour fuel moisture. You can see we were below the minimum for October 14th for this analyzed period. We can go to the next slide. There's going to be kind of the northwest corner of the state, and it's going to be the same thing across the state. For most of the state, we're setting maximums right now, or the last week we've been setting maximums. We are expecting it to decrease, and hopefully that decreasing trend continues. The horizontal black lines are representing the 97th and the 90th percentile. Those can be important. When you look at the 90th percentile, when we're above that 90th percentile, we're calling our fire danger very high. If we're above the 97th percentile, we're calling our fire danger extreme. So you can see right now our fire danger is still at a maximum and very high. We can hop to the next slide, Tony. Thank you. So right here, we're looking at that southwest corner, kind of the same story. It's been a hot, dry year. You can see we were below the average at one point, looking back kind of middle of September. And then the last 2 months been really hot and dry. We've crept back up. Very high fire danger, setting maximums. Next slide, Tony. Right here, we're looking at the Medbo. Same story. Setting maximums. Hoping the trend is going to start falling. You can see we're above the 97th percentile here for extreme fire danger. Hopefully that rain you're getting in Laramie is hitting the mountains over here. Next slide, please. And then Bighorns, I know we have a big fire going on there. And this can be related to stuff that everybody else presented today. All the way back to our snowpack at the beginning of the year, showing below the 100th percentile. And then this last 2-month period being extremely hot and dry has led to extreme fire danger and setting maximums there. Moisture moving in. So hopefully that's going to help out on some of these larger fires. So we're going to look at some longer predicted fire, large fire potential. Looking for the month of October. We often aren't included in this, but they actually threw a little sliver of red in there. And I think that can be confirmed by the fires that we've seen in that area this fall. Great Basin as well, Idaho. They've had some pretty large fires. California, this time of year is generally when they're starting to get some of their significant winds and their fields are starting to go into dormancy or cured. So generally this is a time of year California gets fire. And then you're looking at Arizona. Generally they're not getting as many fires this time of year, but it's been hot and dry across a lot of the country. Jumping over to November, they're looking at Texas, Oklahoma area, and then Southern California. And then December on the next slide, I believe is, yeah, it's Texas and Southern California. And then each month I try and throw in another little helpful tool if people are curious about fire danger or any of the metrics we use or predicted outlooks. This is the RMA dashboard. So I know you guys might not be able to click the hyperlink, but if you Google NIFC RMA dashboard, there is a ton of information there. If you're looking for fire danger for the next day, or if you're looking for fire danger for a seasonal outlook, this is updated on the national level every day. So kind of helpful. That's pulled for today. The brown is representing moderate risk for significant fire. Yellow is representing low risk, and green is little to no risk. And then the orange is generally those places you're going to see red flag warnings, whether it be for wind or heat or dry lightning. They kind of throw a little, it's interactive on their site, so you can click on it and it'll generally tell you why that it's orange and high potential. And then finally, we'll kind of look at some statistics for Wyoming this year. So 2024, there have been 603 fires, and this is data as of the 11th. So last week, and this might change. Some of this stuff's hard to capture in the middle of fire season as we have fires that are still active and gaining in size. We've had 603 fires that have burned 763,000 acres. 255 of those have been known natural cause fires that have burned 295,000 acres. And 384 of them are either unknown or still being investigated, or are known human caused fires for 468,000 acres. So you can see more of our fires have either been in that unknown human, more acres that we've burned this year have been in the unknown or human caused than the natural caused fires. And then if we're going to look back just to 2020 to 2023, in that time period, we had 4,258 fires for 384,000 acres. So over that 4-year period, we burned 384,000 acres. And this year we burned 763,000 acres in 1 year. 2020 to 2023, we did average 1,064 fires a year. So this isn't proven, but my guess is since it's been dry, we haven't had as many thunderstorms. So we've had less fire starts under that natural category. But since it's been hot and dry, even though we've had fewer fires start this year, they've been under more higher fire danger conditions. So we've burned more acres significantly. So 2020 to 2023, we averaged 96,000, so just under 100,000 acres a year. If we're going to look national average, really, we only care about that total column over there for looking at this. So total fires, this year we've had 42,000, and in the box below, generally on this day, we've had 48,000 acres. And then this year we burned 7,800,000 acres. Generally, this day, over the last 10 years, we're showing 6.2 million acres. So kind of the same trend. We've had less fires this year, but we've burned way more acres. So that's all I got, Tony. Thank you.
All right, thanks, Jason. And I'll kick her back to Wendy Kelly.
All right, great. Thank you, Tony. And I wanted to just include this last slide here for resources for the 2024 wildfires. This, you can see the bit.ly link in the lower left-hand corner. And this is a compilation of resources that are available on the University of Wyoming Extension's website in partnership with others. If you're aware of resources that we're missing, after wildfire resources, or looking at the kind of rectangular box, for producers affected by wildfire, the financial resources, if we're missing anything, there is an email address on that website where you can email and ask us to update it. We'll try to keep this as current as possible. So please help us do that and share this with folks who have been impacted, and then also thinking about into the future the before the wildfire. Right now we're in the middle of it and we'll have that after wildfire, but just to know that this is an ongoing resource even after we close up this wildfire season. With that, we'll go ahead and transition to the last slide, which is acknowledging each of our presenters today. You can see their name, who they're affiliated with, and their email address. If you have questions, you can reach out to them. I want to thank all the presenters as well as the attendees for today's webinar. Again, this is a monthly webinar that's the third Thursday of each month at 1 p.m. We do not host a webinar in December, but otherwise you can find us here. I'm going to stop the recording